Hi everyone, soil mechanics. Let's jump to an interesting problem in water pressure calculation at a point beneath a dam. So in this problem, we have a dam and you can see the water elevation at the upstream and downstream side of it. So if the upstream side water level is equal to 45 meters, we can set our downstream side at like our base, and by creating the flow net and like isopotential lines, we want to know if we have like 2 point like M and N, what is the water pressure at point N. So we want to calculate the water pressure at point N by given information. So if we have there are two ways of calculating the water pressure. The easy one is when you have like a piezometer, you can easily uh, locate it inside the static water and read it and calculate the water pressure. But in moving or in a seepage condition or in a moving water, you need to solve the seepage equation in terms of calculation of water head. So that's not that easy like in a uh, stagnant water. So in that case, a U water pressure in a combination of flow network is like H minus Z in parentheses times gamma of water. So H stands for head of water and Z is your height base of your base, which our base is, we put it like we locate it at the surface of downstream. So that's like equal to Z is equal to 0, our base. So, and if we want to calculate the U for any given point, for example, like N, that's U sub N is equal to 8 head of water H of N minus Z of Z sub N times the unit weight of water. So to do so, first we know delta HI. We have to calculate each of these drops, which is the total delta H total over number of drops. If you look at the upstream side, the height of water is 45. Downstream side it's 0. So we just consider our base like here. Hmm? The same elevation, that's ours equal to 0. So 45 minus 0 is 45 over number of drops. So if you count the drops, it's like this. So start from downstream side, move upward, 1, 2, 3, 4, 5, 6, 7, 8, and finally all the way to the upstream. So these isopotential lines from downstream started count them toward the upstream. So these a red one plus upstream and downstream. So that's how you count the number of drops. That's 9 of them. So it just gives us each of delta I. Delta HI is equal to 5 meters. So if we just want to know what delta uh, H at N is, that's 45 at the beginning. If you just climb down, you will reach to the very first of them from upstream side. So 45 minus 1 drop, that is 5. It just gives us 40 meters. So, and at the same time, if we consider our base at here, constant line, it just gives us z is equal to 0. So at n, definitely our z is 0. 40 minus 0 times 10, which is gamma of water in terms of kilonewton per meter cubed. So, and we have to modify this one. This is Newton cubed. That's a unit weight. Mhm. So if that's the case, again, the unit is kilonewton hour meter cubed. We can easily calculate U at point N is 400 kilonewton per meter cubed. And then you can just consider what if we want to calculate the water pressure at like point M. Think about it, and that's pretty easy because any point on this line is a somehow between 45 and 40, so that's almost 42.5. And definitely if we are in M, z is equal to 0, and that's 425, a bit higher than U, water pressure at N. Thank you. We'll solve more interesting problem in seepage and water pressure problem.